Hi, welcome to this video. We are going to talk about polynomial and rational inequalities. This is lesson 5 in unit 1B, and we are going to learn how to solve polynomial and rational inequalities. In order to be successful, you need to be able to find zeros of polynomial or rational functions, determine where a rational function is undefined, and be able to evaluate a rational or polynomial function. Okay, so I do want to go ahead and recap what the heck is an inequality. An inequality is a mathematical statement just saying that two expressions are not equal, an inequality. And here, remember, are the types of inequalities. We have less than or equal to, greater than or equal to. And in order to solve a polynomial or a rational inequality, we will first determine where the function is positive, where it's above the y-axis, and where it is negative. And so here's an example. We have this statement: f of x is 0.2 x plus 4 x minus 1 squared. And if we're looking at this visually, we can easily see where our graph is greater than 0, right, from negative 4 to infinity, or I should say greater than or equal to 0, right, because at negative 4 it's 0 and at 1 it is 0. And it is less than 0 when x is less than negative 4, right, for these domain values. So kind of what I want to go ahead and have you notice about this visual example for polynomials is that we cross the x-axis at negative 4 and at 1. The x-axis is where our graph is going to cross over from negative to positive values. So what we're going to go ahead and do today is we will determine where our polynomial is equal to 0, okay? And then we will go ahead and do a system called creating a sign chart, and we'll test and or we will graph the function in order to determine this, okay? We'll go ahead and I'll come back to rational functions, but again, here are the steps for a polynomial inequality. Find the zeros, place them on a number line, and this will represent the x-axis of the number line, and then we'll go ahead and test. So choose a number on the interval and plug it in. If it's positive, put a positive. If it's negative, put a negative, and then we'll use the inequality symbol to determine which intervals are the solution. Write the solution using either interval notation or inequality notation. So let's go ahead and let's jump into our first example. The polynomial function p is given by p of x equals x minus 4 times x squared plus 7x plus 10. On what intervals of x is p of x greater than 0? What we're going to go ahead and do here is we are first going to determine the zeros. So I guess I should say step 1, what are the zeros? And so I'm going to factor this, and this will help us determine our zeros. Okay, if I set this equal to 0, I get 4. I get negative 5, and we get negative 2. And so what I'm going to do next is I'm going to go ahead and create a sign chart. Here's the sign chart. And I just place these zeros on this number line. Negative 5, we have negative 2, and we have 4. And I might as well as put the infinities over here. This kind of just help you keep that in mind. And so you want to know, okay, p, where is p of x greater than or equal to 0? So really you have two ways to go about this. If you are good with graphing, if you understand how polynomials are graphed and you remember this, especially from the last unit, graphing makes this really easy. I'll go ahead and show that here in a second. But I do want to show you, if you don't know, all you do is you just test. Well, what do I test? Well, pick your favorite numbers to go ahead and test. The best number to test is 0. And so notice I place that on this interval, and I make it smaller just so I know where my zeros are. But now I'm going to go ahead, I got a test, right? So this is step 3. I'm going to go ahead and test p of 0. So p of 0. And I plug this into my function. Okay, you can use the original function, or I like using the factored function because it helps me determine the positives and the negatives, and that's really all I care about. So check it out. 0 minus 4. Well, isn't that negative? 0 plus 5. Well, that's positive. Okay, and I know that those are -4 and 5, right? And when I plug in 0, I know I'm going to get a +2, right? But again, it doesn't matter, and it'll be more useful when I have actual numbers. It saves your brain power and you move quicker. So check this out. If I plug in 0, I have a negative times a positive times a positive. Well, this is negative. So guess what? Our graph is negative there. Okay. Well, check it out. I have 1, 2, 3 more intervals. So I have to do this again for all of these intervals. So, okay, -10, I like, 10s and 1s and 0s. But let's check this out. So, okay, -10 minus 4. Well, that's negative. -10 plus 5. Well, that's negative. -10 plus 2. Well, that's negative. So here I have 3 negatives. This is negative. Okay, next, what am I going to choose? How about -4? It's got to be on this interval. Let's go with -4. So P of -4, what is this? Well, -4 minus -4, that's negative. -4 plus 5, hey, that's positive. -4 plus 2, that's negative. So what do I got here? 2 negatives and a positive, that's going to be positive. Positive. So this interval is positive. And then I can choose this interval over here. Let me choose 10, P of 10. And so we get 10 minus 4, positive. 10 plus 5, positive. 10 plus 2, positive. So this interval is nothing but positives, which gives us positive. Okay, so there you go. There is your sign chart. So where is our graph? Where is our graph greater than 0? Well, our graph is greater than 0 on these two intervals between -5 and -2 and 4 to infinity. And so here we would say just x is greater than 4, okay? Notice I don't include the values. I don't say equal to the values because the function is actually 0 there. So unless this had an underline, I would include them then, but it's not, so I don't include them. Okay, so I think our answer here is going to be C. Answer is going to be C, okay? Now, graphing. I want to go back to graphing really quickly. How could graphing help us out? Well, do you know what this polynomial looks like? It's a cubic, x to the power of 3, right? Your leading terms of positive x to the power of 3. So my right end behavior is going to go up, and my left end behavior is going to do the opposite. So can't I graph this? I could graph this like this. Bink. That's what my graph looks like. So if you can graph it, you know where your zeros are. This section's going to be negative. This section's above, so it's positive. This section's below, so it's negative. The section's above, so it's positive. You can graph, and graphing is a great tool. Okay, let's look at example number 2. The polynomial function m is given by m of x. On what intervals of x is m less than or equal to 0? So again, what I'm going to do is I'm going to factor this, x minus 3, x plus 2. And then I have x minus 5, and again, x plus 2. So what are my zeros here? Well, I'm going to have a 3, we're going to have -2, and we're going to have 5. And we have multiplicity. Notice we have multiplicity at -2, m times 2. There's 2 of them there. So let's go ahead and make our sign chart. Here is m of x, and I'm going to cross at -2, cross at 3, and at 5. Now, I'm going to go ahead and just show you. So again, I could pick values and I could plug and check, but polynomials you should be able to graph. I mean, that was part of our curriculum here. So our leading term here is x to the 4th. This is a positive, so both end behaviors are going up. So what does this look like? Well, I'm going to come from up here. -2, we have multiplicity, so we'll bounce and we'll cross at 3 and then cross at 5. Okay, so where is our graph? Negative, less than or equal to 0. It looks like it's just between 3 and 5. Answer, B. Answer is B. Wasn't that easy? So much easier than, testing. Testing is really important, though, when we get to rational functions. Okay, here you go. I want you to pause the video. I want you to try this example here. Pause me, try this one. All right, hopefully for this example, you were able to find the zeros of 0, -4, and a +2. And if you put those on a number line, if you can graph it, if you can graph it, you know that your leading term's negative x to the fourth, so both end behaviors are going down. This is negative even, and so we'll cross at -4, we'll bounce at 0 because we have multiplicity, and we will cross back at 2. So it looks like our negative intervals are going to be x is less than -4 and x is greater than 2. Answer is A. Okay, there you go. That is how you go ahead and graph polynomial inequalities. I'm going to make a second video where we go ahead and talk about how to solve rational inequalities. Give this video a thumbs up if you learned something. I'll catch you in the next one.